Hello, I'm Sally Gao, and I'll be presenting our case study on evaluating human-in-the-loop topic models in an applied setting. Topic modeling is a statistical modeling technique used to discover thematic groups within a collection of documents. Most commonly, a topic is modeled as a collection of highly correlated words, while a document is modeled as a collection of topics. Recent work has proposed that human-in-the-loop topic modeling, or HLTM, leads to higher quality topic models by allowing domain experts to steer and adjust the creation of a topic model. This is a response to the fact that automatically generated topic models are often imperfect. For instance, they sometimes contain incoherent, missing, or duplicated topics. And on a higher level, HLTM also addresses the need for topic models to align with a user's intended modeling goals. So what makes a good topic model? A high-quality topic model should have two things. First, it should have good predictive performance and downstream data. That is, it should be able to assign appropriate topics to future documents. It should also be interpretable to end users, meaning that its topics should be adequately meaningful, coherent, and well-differentiated to the human eye. HLTM is premised on the idea that humans are better than machines at creating interpretable topic models. It also implicitly assumes that human refined topic models are better topic models in general compared to models generated without human intervention. The aim of this study was to investigate that implicit correlation. We wanted to answer the following questions about topic models created via HLTM. First, are the topics interpretable and thematically distinct? Does the model perform well on new data? And how do users interact with HLTM in applied contexts? We found that HLTM can enhance model interpretability and predictive performance in some cases, but may lead to overfitting on the training data, which negatively impacts model quality. We also found that the best evaluation methods focus on document topic assignments rather than on lists of top words. Now I'll introduce the background of our case study. We teamed up with a workforce analytics group within our organization to study whether HLTM results in high-quality, interpretable, and useful topic models in a real-world setting. Now, this team periodically sends out company-wide surveys to gather data on an employee sentiment. Next, they analyze the free-form textual responses by manually reading them and compiling lists of themes and keywords, which is laborious and time-consuming. A topic model was a natural fit for this use case. We began by splitting the data set into a train set, which was used to create the topic models, and a test set, which we used to evaluate the models post-refinement. First, we created a machine-generated topic model from the train set. Then, we tasked two members of the analytics team with refining it through our custom-built HLTM tool. In addition to giving the refiners a starting point to work with, this initial model serves as a baseline against which we compare the refined models. To evaluate the models, we use a mixture of automated and human evaluation. Two members of the same analytics team who were not involved in model refinement served as our human evaluators. We built a custom interface for HLTM to support this study. Our UI is closely modeled on other HLTM systems that we found in the literature. Using the menu on the right, the user can browse existing topics. The currently selected topic is displayed in the main panel. The upper half of the main panel displays the words belonging to this topic in descending order of importance. Documents that belong to this topic are displayed on the bottom. To refine the model, the user can promote and demote words and documents within a topic, as well as create new topics, split a topic in two, or merge two topics together. We also included the ability to name each topic and to undo up to 10 previous actions. In our interviews, we found that both users trusted the tool and the underlying statistical model, sometimes even deferring to machine judgments against their own intuition. In one instance, when faced with a choice of demoting a word from a topic, one user said they chose not to do so because they thought the machine might be better at this than I am. In addition, we surfaced the need for more document-level explainability within the UI. Both users said they were sometimes confused by why certain words or documents were associated with certain topics. Following previous work on HLTM, our interface primarily emphasizes topic-word relationships. However, our users wanted to be able to see word-level topic assignments within documents, saying that this would have helped them feel more confident in their decisions. The focus of our evaluation was to compare the quality of the automatically generated baseline model with the human refined models. We anonymized the models during the human evaluation test, so the evaluators didn't know which topics came from the baseline model and which topics were created by their colleagues. To measure predictive performance, we use a task called topic identification to test how well our evaluators classified topics to randomly selected held-out documents. We also used an automatic evaluation metric called Normalized Point-Wise Mutual Information, or MPMI. This is calculated using a collection of documents known as a reference corpus. We can measure a topic model's predictive performance using our held-out test set as a reference corpus. To measure whether the topics were interpretable and thematically coherent, we used two human evaluation tests. The first task, word intrusion, measures how well the evaluators could pick out a word that didn't belong in a topic model. In our final test, label concurrence, we asked the evaluators to match a topic label with its top words. This table summarizes the result of each evaluation approach by ranking the models from best to worst from left to right. We found that overall, one of our two human refined models, which we refer to as Model 2, performed the best, especially on measures of predictive performance. On the other hand, the other human refined model, Model 1, performed poorly on prediction, especially on topic identification, where it was worse than the unrefined baseline. Moreover, we saw more inter-annotator conflict for this model than the unrefined model and Model 2. We also observed that our word intrusion findings conflict with the other metrics. Here, Model 1 is the winner, whereas Model 2 does worse than the baseline model. To try to explain these conflicting results, we performed a closer analysis of our NPMI data. Our conclusion is that Model 1 was overfitted, meaning that it was closely tailored to fit the training data at the expense of general performance. When we calculated NPMI on our training data, we found that NPMI exaggerated the quality of Model 1 over Model 2, whereas in reality, Model 2 was a better predictive model as indicated by the test data. This explains why Model 1 did so well on word intrusion, which only takes into account a topic's top words, without regard for how well it assigns new documents to those topics. Although our study is somewhat limited due to its small sample size, we nevertheless revealed some key gaps and challenges for applied HLTM. First, the risk of overfitting means that it's very important to evaluate topic models using held-out documents. We advocate for more widespread use of held-out test sets as opposed to evaluating directly on the input corpus. Second, we question the efficacy of assessing topics solely based on top words, as we found that these metrics didn't correlate well with predictive performance. Lastly, in our user interviews, we surfaced the need for more explainability at the document level. We believe that this is crucial for future HLTM development for the following reasons. First, helping users understand why certain documents belong in certain topics will enable them to accurately judge when or when not to place trust in the system. Second, placing a greater emphasis on documents within the UI is likely to improve the model's ability to assign topics to future documents, mitigating the risk of creating an overfitted model. Thank you for watching. If you'd like to know more, please take a look at our paper, which includes additional user findings as well as details on our technical implementation and a fuller discussion of our evaluation results and conclusions.